Welcome back. Today we're going to look at the three important theorems that you need to know and understand for AP Calculus AB and BC. So I'm going to first explain kind of how and why each theorem works briefly, and then I will explain how to solve problems that involve the theorems. So the first theorem you'll probably look at in your calculus class is IVT, or the intermediate value theorem. And it states that if a function, let's call it f, is continuous on a given interval, we'll call it a, b, and there's some point k that is between f of a and f of b, then there exists some point c where f of c equals k. So the reason that this theorem works is because if we have a y value that we're calling k, and from a to b f of x is continuous, and k is between f of a and f of b, that means k is between this y value and that y value, every single point between these two y values is covered because the function is continuous. Therefore, if k is between f of a and f of b, it must lie somewhere on this graph, and therefore there must be some point c that aligns with the y value k, wherever that may be. So next we have the EVT, or the extreme value theorem. And this theorem states that if a function, we'll call it f again, is continuous on a closed interval a, b, and closed interval signified by these brackets means that it's inclusive of the endpoints. So if it's continuous on this closed interval, then f has at least one minimum value and one maximum value on AB. So another important part of this is not only does it have those minimum and maximum values, they also occur at either the endpoints or at local max or minimum points. So the reason this theorem is so helpful is because when we're giving a graph like f, let's say this is f, and it looks something like this, the only points we have to check for, the only points that could possibly be an extrema are these 2 points, the endpoints, and each of these local maximums and minimums. So we can check these by plugging, say this is A, B, C, D, E. We can plug each of these points into f, A, B, ... and find what the minimum and maximum values are, and then those will be our extrema. So finally, let's look at the MVT, or the mean value theorem. So the mean value theorem states that if a function is both continuous on the closed interval AB and differentiable, meaning can be differentiated at all points, on the open interval AB, open interval meaning not including the endpoints, then there exists some point C such that f prime of C is equal to the average rate of change on AB. And the average rate of change is modeled by f of B minus f of A. So that's the y value at the second endpoint, let's draw a fake graph here, minus the y value at the first endpoint, divided by the x value at the second endpoint minus the x value at the first endpoint. So let's look at how this works. So here we have just some arbitrary made-up graph, and according to the mean value theorem, because on this interval, we'll call negative 2a and 3b, on this interval from a to b, because, we'll call this graph f, by the way, because on this interval f is both continuous and differentiable, there exists some point, we don't know where it is, but some point C such that f prime of C is equal to the average rate of change from A to B. So the average rate of change from A to B would be 4, because that's the y value at B, minus the y value here, so -2, over the x value at B, so 3, minus -2 again. So that would be equal to 6 over 5. So there exists some point C such that the derivative at the point C of f is equal to 6 over 5. So that means there's some little tangent line somewhere here we can draw whose slope is 6 over 5.